Hello, computer science students. Welcome back to one of our last assembly videos, where we're just going to do a really quick one talking about bit shifting and what its effects are. So there's a section in your online textbook here, 14.3, which is shifting bits. And so you can go here to reference the different types of bit shifting we can do and why we would use one or another if you would like. But for now, we're just going to jump in and use it for our purposes here. So let's create a program. We're going to use the nano editor. We'll call this one divide by 2.s. So we'll start with our comment. Again, divide by 2.s is the name of the program. This program divides a number by 2 using bit shifting. And your name. And we'll use .syntax unified and .global start. And we'll create a start label. Okay, so this is the stuff we do for every one of our programs. And so hopefully, having done a few now, it's starting to come to you as you program. And so now let's take a number that we want to divide by 2. We'll store it in R1. Since we're not using strings, R1 is not as critical. It's not used for printing strings. So we'll move 11 into R1. And then this is where we're going to use our shift command. So we're going to move into R0, R1, but logical shifted to the right 1. That means we're going to use a logical shift. If you want to know the difference between logical and arithmetic and rotate right or whatever, you can look it up in your textbook, but I'm going to do a logical shift to the right by 1 bit. All right, so what does this mean? So let's say we had 1 0 1 0 1 0 1 0. So an 8-bit number that was 1 0 1 0 1 0 1 0. So if we do a logical shift, if we do an ls logical shift to the right, the result of this would be 0 1 0 1 0 1 0 1. So what we really have done is taken each bit in the original and moved it to the right. Actually, this was a terrible example because you can't see the pattern, but we'll do another one. Logical shift to the right, the furthest rightmost bit, the 0, gets dropped off, and everything else moves to the right, and we fill in the missing bit on the left with a 0. This is a terrible example because you could do the same thing shifting to the left and you just fill in a 1. So let's try this another way. Let's do another example here. Let's do a logical shift left with 1 1 1 1 0 0 0 0. That'll be better. So we'll do a logical shift right. A logical shift right by 1 bit. What does that translate to? We go 0 1 1 1 1 0 0 0. So we moved all the bits to the right 1, and we filled in a 0 wherever that missing bit would be. And the 0 that used to be on the least most significant 0 is just gone. Okay. So this is a logical shift to the right by 1 bit. All right. Well, it turns out in binary, let's run an example here. If we had the number 8, hopefully you all at this point can read this and see that this is the number 8, and we do a logical shift right 1, we're going to result in 1 2 3 4 5 zeros, and then a 1, and then 2 zeros to finish it off. What is this number in binary? It's 4. And in fact, because every digit is a power of 2 greater, if you shift all the bits to the right 1, you're effectively dividing by 0. So dividing by 2. I don't know why I said 0. We're dividing by 2. So we're going to be able to see that here when we exit our program looking at register 0. Maybe register 0 was what was throwing me off. So we move 1 into register 7, saying when we get our interrupt, exit the program, and then we're going to get our interrupt. So escape, save, hit enter. All right. Let me go ahead and mouse up to assemble our divide by 2 from a .s into a .o. We're going to link from our object file, we're going to go divide by 2 from divide by 2.o. And then we're going to run divide by 2. Nothing printed out, right? We didn't have strings. We didn't print strings to the screen. We didn't have print statements. So does anybody remember? Do y'all remember how do we find this? How do we see our printout? Well, it's echo $? Which is basically print out what the remainder was from our last function call, and the number's 5. So 11 divided by 2 got us 5. Really, it should be 5.5. But remember, that least significant bit just gets dropped. So anytime you're doing an odd division, it rounds down. That's essentially what that translates to. You can go back and look if you'd like. We can do another really quick even division. Let's move our cursor down here. Let's do a 12. Assemble it, link it, run it, and get the result, and it's 6. Right, so 12 divided by 2 is 6. So we can see that with this program, when we divide by 2 this way, the least significant bit is basically chopped off. So 11 divided by 2 would be 5.5. The half gets chopped off. This is integer division, right? So 12 divided by 2 is 6. All right, so hopefully that helps get you a feel for what shifting bits left does, shifting bits right does. Shifting bits left is like multiplying by 2. And we could run that as well, but I'll let you guys do that on your own time. If you have questions, let me know, and I'll look forward to seeing you next time.